So this would be the landing page of our openCARP project. Normally you would get the latest information here, a bit of a background. So it's just the front page. So if you are going to enter our community, maybe getting started is a good point. So you get a little bit of information about if you're new to Carb, which pages to consider first, and if you're experienced, what then else to get. And then next point would be about. About is subgrouped in different headings. It's first of all the ecosystem. It's a bit what we will also discuss here today. So you've heard many of these components of the openCARP ecosystem, and we will go later on also a bit more into detail of other things. People behind, that's what we've done earlier. Governance, you can read through it. I think it's not really important right now here. And also the software management plan is listed. Then we come to the section download. Probably a few or all of you have been already at this section here. First of all, here we have our installation. So we are currently providing 3 different kinds of installation. It would be installation packages. This is like if you go to the App Store and download a software, that's a bit what we want at the end. Currently, the visualization software Measurealizer is not included, but we're working on this. So probably in a few weeks, you should have an installation package that involves everything or includes everything that you need for running a simulation. Additionally, we have Docker. Docker both for the Carb utils GUI that you will see later on, and also for the Carb itself. This might have the advantage of easy installation also on remote machines, which run Docker. And for sure, at the end, you can also install openCARP from scratch if you are a bit used to command line and all these things. The only thing where you really can interact with the code and maybe change optimization flags or even work on giving us feedback or contributing would be here on the source software level. As we heard already, we have different components. It's the openCARP simulator, that's a C code or C++ code. We have the Carb utils, that's the experiments that you can define, that is Python. And we have mesh tools to generate meshes, as we heard earlier, and it's a so-called Measurealizer. That's a visualization software written by Ed. And on this page, for sure, you can find different further information. If you want to go to our source code, this would be a GitLab installation. Most of you probably have already registered for this, and for those who really want to contribute and become later to this, this is how you would interact with us or integrate new or further components. Yes, maybe licensing again. So again, this is important. If you are aiming to use the openCARP simulator, the C code, in a industry-driven project, please contact us first. We need to figure out if that is within the so-called academic public license or not. Carb utils and Measurealizers are both open source, fully free open source. Okay, let's go to documentation. Let's start with the example. So that would be the point where either you as a beginner would start looking at, and in the beginner's track, we will also go through some of these examples here. But also if you have new students that you want to train, this would be the spot where they should start working on. So each of these examples here are really like tutorial-based things where a lot of information is given. The input parameters are described and tasks are provided so that people can go through So this is also within the Carb utils framework. So we distinguish between Carb utils experiments, that would be for simulations, and Carb utils examples, and this is what you see here at the end. If we generate a new example, then it will automatically also appear here on the web page. Additionally, for those who start working in this direction, we have provided already some video tutorials, and we will provide further video tutorials over the next half a year, I think. So there are video tutorials about basic electrophysiology, about Hodgkin-Huxley concept, and how to, for example, use the so-called EasyML, the markup language to describe modeling, and transfer it into the openCARP ecosystem. Additionally, there's a few other things that are probably more important if you really start working on either the code or a Carb utils experiment. So, for example, if you start working on an experiment, then you want to know a bit more about the simulator, and here there's a PDF that we generated with all the parameters, but also for sure at the beginning a bit more information about the system itself, how to get it, how to install it, how to install PETSI, and all these things. And later on, I will go through. Here's a bit of a mathematical background that you can get, and all the way at the end, you see that we also explain all the parameters that are used in the simulation code a bit more in detail. And these are also available as online version. So there's these openCARP online parameters, where one, for example, if we look at G region and want to know what is possible, then you get all the information of what these parameters mean and what you can change with them if you change them on the simulator level. Then we have a Measurealizer manual. So if you're going to want to use the Measurealizer tool, you also can use ParaView or other visualizers, but currently Measurealizer is the, let's say, Oldsmobile kind of a software. It still runs very well, and it's comfortable, but for sure there's newer cars out there. And if you're really going to or want to develop either code components, then you have the openCARP code documentation, or Carb utils components, then we have the Carb utils code documentation. These are both Doxygen type documentation. So it's both based on Doxygen. And then we have one further information. If you've worked before either on Carb or on carpentry, we have a list of things that you may need to consider if you are switching to openCARP. And the last point here is now the community platform, or the community related things. The first one, the question and answer system. Maybe you've seen this already. So whenever you have a question, or if you read a question and have a nice answer, please contribute to this, because this should be like the living system of how to help one another. So it's not totally meant that you ask a question and we answer, but also that this is lively, and if you know some answer to a question, please contribute also answering questions. For sure, currently we are doing most of the jobs of answering, but I hope in future this will change. Then we have the newsletter. For those who are not, probably all are in the newsletter because you would not be here. User meetings, you have been to this webpage. Then we have a page about what users we are currently having, how to use the issue tracker. So if you, for example, find a bug or think there's something wrong, please open up an issue in our issue list here. Then we have a contributing component. So if you are really thinking of, oh, that's a cool project and I'm keen on going further, please read this first. How to integrate. So what one would normally do if you're working on either the Carb utils or the openCARP simulator, that you would in GitLab generate your own branch of Git, maybe change things, add things. Maybe you have a cool new feature. Then you come back to us and one of the maintainer will have a look at the code. And if both you and the maintainer are happy about how the current system is set up, then we will integrate it into the master branch, so-called master branch. For this at the end, we would need a contributor agreement from you. You can find it on this page here. That need to be signed because, yeah, it's a license agreement that we are having here with the academic public license. And at the end, please, if you're really aiming more to be involved, please also read the code of conduct, because that's a bit of how we are going to work with one another. Okay, related to GitLab, I am not totally sure if you all know GitLab. This is far beyond what we are going to do today here, but you will probably not see as many projects as I see because I'm a maintainer. You will probably see openCARP and probably Carb utils GUI and Carb utils. And within these projects that are public, you can participate, write issues or other things. If you need further instructions about GitLab, please just search the internet. There's plenty of good examples of how to use GitLab. Okay, I'm going to pass over again to somebody else. It's probably this time Oral, and he will tell you a bit about openCARP roadmap. So what's going to be coming, or what's the current development?
Okay, so please, Gunnar, go to the next slide. Okay, so the first item is the simulator, the simulator engine itself. There, I think the most significant contributions for, let's say, the initial version have already been done, but we still want to improve some things that I have listed here. For example, the whole workflow of generating new dynamic models. So these dynamic models are models that can be added or loaded by the simulator without having to recompile a simulator, which is very convenient. We want to improve this generation workflow so that more people that do not want to build a simulator can still create new ionic models and use them. And we are not satisfied with the current workflow, and we will be working on that. Another aspect that we want to improve is the I/O. So one thing that is going to be added is asynchronous I/O, which is will be funded in the microcard project. And also additionally, we want to add new output formats so people can more conveniently have different kinds of visualization tools. Currently, what you can do is convert the Carb output with mesh tool into, for example, Nsight or this VTK collection. I think for ParaView, the most performant solution right now is to use the Nsight format, where you don't have to reload the mesh in every time step. You only reload the data. With the default VTK, you also reload the mesh. Okay, and then what we will also be adding or continuously we are working on improving or lowering the threshold so that people can implement own physics or own adaptation of the current physics in openCARP. I think the majority that I know of are in Gernot's lab, which want to transition their code on using the openCARP base, and there will be changes done to reduce overhead here. And of course, we want to improve the user interface. What I mean with it is how the input structures, how they're structured, how they're working, how they're parsing the input, and so on, to reduce syntactical errors that can cost time, and want to improve the documentation. And on the next slide, just some minor things that will be added to Carb, or not so minor things, but there are not so many of them. In my opinion, Carb utils should always be reactive to what the simulator is doing, and will not have so many things in addition to the simulator, but just enabling you to use the simulator. So one thing that we want to enable you to do is to package experiments. So you wrote up something, and even though most of the things that or most of the parameters, let's say, are encapsulated already in your Python script, in this Carb utils script, still there are some things missing, like the mesh, some other input files. So we want to provide a packaging mechanism to help the sharing of experiments, and later on they will also be hosted in the openCARP project. Also, we want to go in this direction. We want also to support additional output formats that maybe help you let's say, for example, what we already have is outputting a bash script of your experiment, or outputting, for example, an XML description of your experiment, so you can parse it in some other tool. So there will be minor additions coming in this direction. And then, of course, what we are well aware of is that documentation has to improve, and especially providing more examples of and use cases of how to use Carb utils. That's about it.
Yeah, thanks, Aurel. Then I pass over to Axel, who will tell you a bit about what the SOLMAS project or the infrastructure project is going to do in the next month or years.
Yeah, and to resolve the mystery, this cryptic acronym stands for Sustainable Lifecycle Management of Scientific Software. And one aspect of that is really infrastructure for research software, which is being partly developed in this project, but mainly tested and then really put on the road for the openCARP project. And what you see on the right is a bit of a summary of how this whole openCARP ecosystem looks like and what feeds into what. So we've heard about the simulator, we've heard about the Carb utils framework. And what's in gray there is sharing experiments. So that's the aspect that Aurel already mentioned on the Carb utils level. So what we really want to do there is to provide an automated workflow that would encapsulate all required files, and then also provide the infrastructure to upload this bundle, which will also include the relevant metadata, which will be extracted automatically as far as possible, and then upload that to a research data repository where it will be citable. So a DOI will be minted, a persistent identifier, so that others can reproduce your results, that others can also reuse the things you've done and extend them, and really move towards open science there and contribute what we can contribute. So that's one aspect which is going to come on the infrastructure side. Another one is really to further develop our continuous integration and delivery pipelines. That's where Carrie has put a lot of effort and thought into. And I'm convinced that this is really a crucial aspect when making this software ecosystem sustainable, that if we release a new version, We don't have to care about updating the documentation on the web page or generating a new PDF. This is all automatically extracted from the source code and uploaded to the web page. New Docker images are being built automatically. And this really lowers the amount of manual effort we need to put into there for routine tasks. For sure, the documentation still needs to be written. It needs to be in the code. It needs to be up to date there, but we don't need to care about synchronizing it across the different channels that we distributed. And we want to include Meshalizer also more in this pipeline. Since a couple of days, you can already find the manual on the web page, which is automatically generated for new releases. And this will be another aspect. Next slide, Gunnar. We don't have much more on the list for now, but of course, we are eager to learn about your experience, to hear your feedback, what you would think is important or beneficial for you. This is a community project. So far, we have 5 major players in there, but we are more than happy to have new contributors. So really a warm welcome to come and join. Just look at this contribute page where we really describe ways to start contributing and hope that they are low threshold and that we provide a good platform for the community as well.